I'd like to try another example here of the alternating series test. We're given -1 to the n plus 1 over n. We want to show that it converges and determine how many terms would be necessary to estimate the sum to within 0.01. So here, let's take our bn to be 1 over n. We do have that that's decreasing. Bn plus 1 is less than Bn. And we do have that the limit of Bn equals 0. So our two conditions are satisfied. That means the alternating series converges. So the sum of -1 to the n plus 1, Bn, that's B sub n. We can say that that certainly converges by the alternating series test. So that's the first part of what we had to do there. We had to show that that series converged. And then we have to determine how many terms are necessary to estimate the sum to within 0.01. So remember, the error when you use the alternating series test is bounded by an plus 1, by the first term that you cut off. And so we want that to be less than 0.01. 0.01. So we want an plus 1 to be less than 0.01. Well, an plus 1 in absolute value is 1 over n plus 1. That should be less than or equal to 0.01 is the same as 1 over 100. So if we take the reciprocal of that, remember, that reverses the inequality. So this is n plus 1 is bigger than or equal to 100. So n would have to be bigger than 99. So we would need 99 terms. We would need to add up 99 terms of this series to get an estimate that is within 0.01 of the true answer. In fact, on the computer earlier, I did add up 99 terms of these series. It turns out that S99 is approximately equal to 0.698172. So if you actually add up all those 99 terms, that's the approximate answer that you get. This series is another one that we can figure out using some techniques that we're going to learn later on. So later, we're going to learn about Taylor series. I don't expect you to understand this yet because we haven't developed the machinery for it. But later we'll learn that the Taylor series for the function natural log of 1 minus x is the sum from n equals 1 to infinity of -x to the n over n. And so if you plug in x equals -1, then we get natural log of, if you plug in x equals -1 here, you get natural log of 2 is equal to the sum of -1 to the n over n, which is exactly the series that we've been trying to estimate. And so the true sum of this series is in fact natural log of 2, and that turns out to be approximately equal to 0.693147. So the true sum, using techniques that we haven't really developed the machinery for yet, is 0.693147. What we got was 0.698172. So in fact, we were within 0.01 of the true sum. So just to recap there, what we were trying to show is how many terms do we need to estimate the true sum to within 0.01? Well, we have this error formula that says the error is bounded by the first term that we cut off, the n plus 1 term. So we set that less than 0.01. We'd like the error to be less than 0.01. we solve that out and we get a value of n, and that tells us how many terms we need to take to estimate our sum.